Hi, welcome to section 6.1, the Pythagorean theorem. Okay, in this section, we are going to define the Pythagorean theorem. So my goal is to kind of show you where it comes from instead of just giving you the equation. And then we're going to use it. Alright, so let's define the Pythagorean theorem, and there's many ways that we can prove it and show you the relationship, but I'm going to use what we know about area to investigate it. Alright, now the Pythagorean theorem only deals with right triangles. And so what we're going to do first is I have this right triangle. And I'm going to write down the length of my one leg is 3. Because I can see that 1, 2, 3. And the length of my other leg is 4. So we're going to use a concrete example first, and then we'll move on from there. So now what I want to do here is I am going to make a square that has one of its sides of length 3. So here's my first square. It has a length of 3, so that means it also has a width of 3 because it's a square. And I'm going to do the same with the 4, the other leg. So I'm going to make a square, and that also has 4. And then I'm going to also make a square using the hypotenuse, and that's what it looks like. So now what I'm going to do is I'm going to find the area of each square. So the area of my little square is 3 times 3, which is 9, and the area of my other leg would be 4 times 4, which is 16. So I'm going to take this third square and I'll move it. And I'm going to do some rotating. And we'll move it a little bit more. If it wants to move, there it goes. And now I can use the squares to count. 1, 2, 3, 4, 5. It's a 5. 1, 2, 3, 4, 5. It's a 5 by 5. Well, the area of that is 25. So now let's see my relationship here. Let's add my two smaller areas together. So I can see that 9 plus 16 is equal to 25. Okay, so we're saying that the area of my square formed by my first leg plus the area of my square formed by my second leg equals the area of my square formed by my hypotenuse. Alright, so now let's break this apart a little bit more. Well, how did I get 9? I took 3 times 3. How did I get 16? I took 4 times 4. And how did I get 25? I took 5 times 5. Well, let's break that up a little bit more. Well, 3 times 3 is the same as 3 squared. And 4 times 4 is the same as 4 squared. And 5 times 5 is the same as 5 squared. Okay, now let's talk about and use some words now. The 3 represents a leg, because legs form the right angle. So I could say a leg squared plus the other leg, which was my 4, is equal to my hypotenuse squared. Well, we don't like writing words in math. We take shortcuts. So we just say, whenever I have a right triangle, we use common letters to describe the legs, and we say the legs can be A or B. It doesn't matter the order, but the hypotenuse is always C. Now, you can use different letters. It doesn't matter. This is just the most common that we see. So in other words, A squared for one of the legs plus B squared for the other leg is equal to c squared for the hypotenuse. So the Pythagorean theorem is a squared plus b squared equals c squared, and this is used to find missing sides of right triangles. Okay, so there it is. Now, I just showed you one specific example with a 3, 4, 5 triangle, which a 3, 4, 5 is called a Pythagorean triple. So let me show you that it works for any right triangle. So here I've got this right triangle, if you guys can see it. Watch what happens when I take the area of the gray and the area of this other one. So there's the area of my two legs. And if I move them, they have the same area as the hypotenuse. Okay, so here, let's move it right here. There we go. Let's start over. I made a different size triangle and I moved it around a little bit. The areas add up to the area of the hypotenuse. So that's a Pythagorean theorem. So now let's just do some examples. Alright, example 1. Apply the Pythagorean theorem to find x and y, and then we're going to find the area of the rectangle ABCD. When you do these problems, I want you to write down the Pythagorean theorem every time so that you remember it. We know that a squared plus b squared equals c squared. So we're going to say a is 3, and then b is 4. And we don't know c squared, so you can leave it c squared, or you can replace it with x, that's fine. So this is 9 plus 16 equals x squared. Well, 9 plus 16 is 25. Okay, the operation that undoes squaring is to find the square root. So we're going to do it to both sides. Square root of 25 is equal to the square root of x squared. And square root of 25 is 5. And square root of x squared is just x. So it's a 3, 4, 5 triangle. Alright, let's try the next one. Do the same process. I want you to write a squared plus b squared equals c squared. Well, in this case, c is my hypotenuse. So c is 10. So we're going to have 10 squared right here. Always got to be careful. 6 can be either a or b, so we might as well just go right here. And then we'll label y as a. So I have y squared plus 36 equals 100. Subtract 36 from both sides because I want the y squared by itself. So y squared is equal to 64. Okay, to figure out what y is equal to, I take the square root of it. So y is equal to 8. Okay. Alright, and my third example is I want to find the area of this rectangle. Before I can do that, to find the area, I need length times width. So I need to find b. So in order to find b, we got to use the Pythagorean theorem because we have a missing leg. So a squared plus b squared equals c squared. Well, we'll let a equal 7 in this case. We'll let b be itself. And c will be 12. This is 49 plus b squared equals 144. If I subtract 49 from both sides, I have b squared is equal to 95. So we're going to take the square root of that. Now I don't know the square root of 95, so I'm just going to leave it like that. You can type in your calculator, but we really don't need to. Alright. So now I want to find the area because I'm not done yet. Area equals length times width. Well, my length is b, which is the square root of 95, times my width, which is 7. So we can just simply write it as 7 times the square root of 95. You cannot take 7 times 95 because the 95 is underneath the square root sign. Alright, let's try another problem. This time we want to determine if the triangles are right or not. If the Pythagorean theorem works, the triangle is a right triangle. If the Pythagorean theorem does not work, it's not a right triangle. So that's all we're checking out. So we're going to check out to see if the Pythagorean theorem works. So we're going to say a squared plus b squared equals c squared. So we'll say a is 13 squared, b is 6, so we have 6 squared, and c is 15, so we got 15 squared. This is 169 plus 36 equals 225. I'm going to add these two together and I get 205 is equal to 225. Wow, that's a false statement because they're not equal to each other, so this is not a right triangle. Okay, so let's try the next one. Let's do the same thing. We have a squared plus b squared equals c squared. Alright, and a we'll say is 15 squared, b is 20 squared, and c is always the hypotenuse, that's 25 squared. 15 squared is 225, 20 squared is 400, and 25 squared is 625. We are going to add these two together, and this gives me 625 is equal to 625. Oh, that works. So this means yes, this is a right triangle. And that's basically how you use the Pythagorean theorem. Thank you.